out your note sheet on that. The first thing we want to do is to define matter. Matter is anything that has mass and takes up space. And there are 3 states of matter: solid, liquid, and gas. I'll leave that there for a second so you have a chance to copy that down. Okay. When you're talking about the different states of matter, like solid, liquid, and gas, we have to remember that a solid does not flow. It does move, but by move, we mean that the atoms in the solid will like vibrate. Now, we can't detect that vibration, but chemists have measured it and know that like all atoms, even when they're bound to other molecules in a solid that seems like it's just not moving in any way at all, the atoms themselves will have this what's called vibration energy. It's called static vibration because you don't go from place to place. Static means stays the same, but it does vibrate. As a solid heats up, and that's what we mean by increasing energy over here on the left. As a solid increases in energy, as we add energy to a solid, like heat, then that solid, its molecules or atoms start to separate from each other because the heat or the energy causes the molecules to vibrate so much that they actually will separate from one another. And the solid becomes a liquid. And so we go from solid to liquid when we add energy. And if it helps you, you can think of energy as heat. Liquids flow, and we mean fluid flow, which means they take the shape of their container. And you can go from a liquid to a gas, or we go from a liquid to a gas when we add more energy to the system, more heat to the system. The molecules go farther apart from each other. They're moving even faster, and then they still take the shape of their container, gases do, but the molecules or atoms are far apart from each other, and so they expand. And so what I've just explained to you is that as you increase the energy on a certain given material object, that matter can go from its solid form to its liquid form to its gas form. And conversely, it becomes less and less dense as it goes this way. And if you went back the other way, if you went from gas, like steam, to liquid, like liquid water, to solid, like, then you would be increasing the density, which means you would have more atoms or molecule per given amount of space as a solid than you would as a gas. Now, I really shouldn't have used water as my example up here because water is actually the one exception to the rule that as it goes from liquid to solid, water actually gets less dense, which is why ice can float on water. The solid form of water can float on its liquid form. Okay. So we want to think about what an element is and what an atom is. Elements are pure substances that can't be further broken down into simpler substances through ordinary chemical reactions. An atom is the smallest unit of an element. So, for example, hydrogen is an element. You can't break down hydrogen into anything else, anything smaller than hydrogen just by carrying out a normal chemical reaction. And if you wanted to know the smallest unit of the element hydrogen, it's a single hydrogen atom. And I think I told you earlier that the vast majority of the mass of all living things is made up of just 6 elements, and we remember with the CHNOPS, so CHNOPS. Those elements are listed here, and you need to know their chemical symbol, so like the C, and then you also need to know what C stands for, like carbon. And just be careful because you know, N is nitrogen, not nickel, and S is sulfur, not sodium, you know, so just make sure that you really know what each one stands for. Let me go and get your worksheet for a minute and see. Okay. The definition for an element, for an atom, you're writing down the 6 most common elements in all living things, not just the letter symbol, but what that letter symbol stands for. And now we're going to talk a little bit about atomic structure. Okay. I know that you learned this in elementary school, but an atom is made up of a nucleus and electrons that orbit around the nucleus. And I have a picture there for you in your notes of a carbon atom. And you see in the carbon atom the nucleus, which has 6 protons and 6 neutrons, because that's what the nucleus has, are protons and neutrons. And then you see 6 electrons orbiting around the nucleus. So you notice on your sheet that there's like a little key, and you notice by the electron there's a negative symbol because electrons have a negative charge. By the proton there's a positive symbol because protons have a positive charge, and by the neutron there's nothing because neutrons are neutral, they do not have a charge. Okay, and that is just what I was saying here. This top part of the slide is already written for you on your diagram. Okay, all atoms of a particular element have the same number of protons. So the atomic number, we would say, is the same for all atoms of a particular element. That's your first blank. Atomic number over on the left, and on the right it lists things that are true about the atomic number. The atomic number, first blank, is the same for all atoms of a particular element, which is right here. What that means is there's the same number of protons in an atom. The atomic number is the same as the number of protons in an atom. Okay. So if we wanted to define atomic number, the atomic number is the number of protons in an atom. And the atomic number of an element is always the same for all atoms of that particular element. So in other words, all hydrogen, hydrogen has an atomic number of 1, which means hydrogen has 1 proton in its nucleus. And all atoms of hydrogen have only 1 proton in their nucleus. And only hydrogen atoms have only 1 proton in their nucleus. So the atomic number of an element really does define it. And every element has, what that means is that every element has its own atomic number, and that atomic number tells a person how many protons that atom has in its nucleus. Now, this last line here is talking about how in a single atom, the number of protons is equal to the number of electrons, and the overall charge of the atom is 0. So your 3 blanks on that last line there are protons. Number of protons is equal to the number of electrons, second blank, and the overall charge of the atom is 0. And we know the overall charge of the atom is 0 because if every proton has a +1 charge and every electron has a -1 charge, and if you have an equal number of protons and electrons, then they the charge is overall is 0 because you have 6 positive, 6 negative, so they kind of cancel each other out and there is no overall charge to that atom. Now I'm going to stop here and hope that I don't mess everything up again, and hopefully show you a couple of the videos that were embedded in your Canvas lesson. So this is the first video, and this video is going to just give us, whoops, not good, okay, is going to give us sort of a tutorial on atomic structure.